A new guide could help groups weigh the costs of construction for fusion energy. The Department of Defense is investing in domestic production of one critical mineral and demonstrating the focusing and defocusing of light without a lens. All your industry headlines are on Photonics Spectra Now. Photonics Spectra Now is brought to you by SmartAct, your partner for high precision in positioning, automation, and metrology. Visit smartact.com to learn more. And by Hamamatsu. Photon is our business. Go to hamamatsu.com for more info. This is Photonics Spectra Now, covering all the latest news and developments across the industry. I'm Joe Kaczynski, Senior Editor with Photonics Spectra. Lightmatter has unveiled what it's calling a foundational advancement in laser architecture, and it's also announcing collaborations with several high-tech groups to advance co-packaged optics. Now we're hearing from Lightmatter CEO Nick Harris on the impact of these moves. Embodied in its guide light engine, Lightmatter says its very large-scale photonics, or VLSP technology, will create the industry's most integrated laser platform. By supporting an 8 times increase in optical bandwidth density, officials believe this will offer a photonic interconnect roadmap for AI. As for those new partnerships we mentioned, by pairing with Cadence, Lightmatter will develop CPO solutions integrating Cadence's silicon-proven high-speed serial deserializer IP with its own passage optical engine. In work with Synopsys, Lightmatter will, in a similar fashion, integrate their IP solutions for its passage optical engine. And through a collaboration with Global Unichip Corp, Lightmatter will work to accelerate the process of bringing passage 3D co-packaged optics solutions to market. We reached out to Lightmatter CEO Nick Harris to ask how this list of developments will impact the company's position in the industry for AI advancement. Here's what he had to say.
Quote, "These partnerships demonstrate the maturing of the CPO supply chain. New technical engagements with Synopsys and Cadence aim to provide our customers with multiple best-in-class, optics-optimized, serializer, deserializer, and universal chiplet interconnect express IP options. Our collaboration with Global Unichip Corp is particularly significant as it leverages its world-class expertise in custom ASIC design to integrate our partners' SerDes and Express IP based on the most advanced 3nm modes."
MicroVision, a provider of advanced perception solutions in autonomy and mobility, has reached an agreement to acquire assets from Luminar. In January, Quantum Computing Inc. entered the stalking horse bid to purchase assets from Luminar after acquiring Luminar Semiconductor for $110 million. With a competing bid of $33 million, MicroVision will now gain IP and inventory related to Luminar's Iris and Halo lidar sensors. The deal is expected to be completed over the coming days. For companies and researchers grappling with ways to commercialize fusion technology, Lawrence Livermore National Laboratory scientists want to help. They've released a 32-page user guide designed to help assess the economic impacts and design trade-offs of building an inertial fusion energy power plant. That guide comes direct from LIFT, the Livermore Institute for Fusion Technology, and could help groups to better understand cost estimates related to design choices. You can check the comments in this video to get a complete look at that guide. In a move that could reduce America's dependence on foreign nations for critical minerals, the Department of Defense will invest more than $18 million in expanding the refining capacity of germanium. Germanium is a crucial material in optics. It's transparent in the mid-infrared, has a very high refractive index, and boasts exceptional thermal properties even in harsh environments. DoD officials say the next generation of optics for surveillance and targeting will be key, making the domestic production of the material a top priority. Funds for this investment will come from a Biden-era act to supply support to Ukraine. Physicists from the Harvard John A. Paulson School of Engineering and Applied Sciences have demonstrated a new way to structure light without a lens. Researchers from the lab of Federico Capasso have reported the first experimental demonstration of the Montgomery effect, in which a coherent beam of light seems to vanish, then refocus itself over and over in free space at perfectly placed distances. Using a spatial light modulator, they were able to carefully sculpt the phase of a laser beam so that it could meet the conditions needed for self-imaging. This repeatable patterning of light could lay the groundwork for powerful new tools in areas of microscopy, sensing, and quantum computing. And a joint project between Veeco Instruments and imec could open the door to a manufacturing process to integrate a unique material on a silicon photonics platform. Barium titanate, or BTO, can be used for high-speed and low-power light modulation in optical transceivers, quantum computing, lidar, and XR applications. A molecular beam epitaxy process developed by the companies is designed for the natural growth of BTO single crystalline thin films on silicon. The companies call this finding a monumental step forward and said allowing for the integration of BTO onto a 300mm silicon platform will enable a greater use of electro-optical materials into silicon photonics. If you want to learn more about these stories, be sure to go to photonics.com for our in-depth reporting on these advancements and complete coverage on all the biggest headlines from the industry. And if you're interested in learning more about inertial fusion or photonic supercomputing, check out the Photonic Media YouTube channel. There, in the All Things Photonics podcast, you can find our episode speaking with two scientists who met at Lawrence Livermore National Laboratory discussing their thoughts on fusion. You'll also see our interview with Nick Harris, CEO of Lightmatter, as he discusses the future of his company and what's next. I'm Joe Kaczynski, and thanks for watching.